So today, I think Sarah started the substation unit. Today, I'm not going to teach you. We are going to see some videos related to substation, so that you can better understand. So that after that, my role is very simple, because the substation, rather than studying, once you see some practical videos, animation videos are there. Once you see the practical animation videos, what is exactly happening in the substation, like a process, how it is starting, incoming, outgoing, and how the fault is being cleared. Like that, if you see some videos, I think it's more than enough to write that particular unit. So today I will share some videos for you first. Then in between explanations also I will try to give the in between. Okay. So just wait a second. So first we'll start with yeah, this is 33 bar 11 kV substation. It is audible. The video is audible.
Yes, sir.
Yeah.
It is not visible. The video is not visible, sir.
Yeah.
Video is not visible, sir. Only audio.
Audio is coming. Video is visible.
Video is
Okay.
coming.
Okay. Okay, 1 minute. Mute your
Sir, now it's
now it is visible.
yes, sir. Now it's visible.
Yes, sir.
It is audible.
Yes, sir.
Yeah. So DCB is nothing but vacuum circuit breaker. Current transformer for measuring the current. I think you are studying in the protection subject. Lightning arrestor. So that is the power transformer, 5 MVA. So this is the 33 bar 11 power transformer, 5 MVA. It's repeating. So you have seen like the circuit, like current transformer and potential transformer. So current transformer is for measuring the current, because the current in the power transformer will be of very more. Okay, so it is in mega amperes. Okay, so it is not simple to measure. Okay, so as you studied in your protection subject, it is not very simple to measure mega amperes. If you if you design an equipment also, it will becomes very big and very costly, and that too directly you can't measure that much current. So what we are doing is we are going for some like current transformer. Okay, current transformer. So mega amperes to some like amperes, like 10 amperes, like 15 or 20 amperes we are reducing. Okay, So that this is in 1 mega amperes means that is the winding that they made, it will show like 10 amperes. So 1 mega amperes as 10 amperes. So 10 amperes means in the line it is measuring like 1 mega amperes, like that they measure. And also potential transformer. Potential transformers also, the voltage in the in the line will be of 33 kilovolt or 66 kilovolt, 110 kilovolt. So 110 kilovolt directly we can't able to measure. In our houses directly we can measure in the plug point. If you go now, if you take the multimeter and you can measure like 230 volts or 5 amperes, 10 amperes, 15 amperes, you can easily measure. But if you take a multimeter also into that, you have to design a special multimeter that is of very, very costly. And also if any a small the winding you have to make is very, very big. So simply like that, if you install current transformer and as well as potential transformer, it is very easy to measure the voltage and current, and as well as the circuit breaker for tripping your circuit, sudden tripping your circuit. I'll show you some other videos also. It will be so that you can understand much better. Yeah, 1 minute, 1 second. So first is transformer circuit, then switch bay components. The whole thing we call it as switch bay components. Then line circuits. Yeah, here is overhead line, underground cables, reactive power plant, and yeah. So first is this is the power transformers. Power transformers, disconnectors for sudden disconnections. We can use for use this disconnectors. Then circuit breakers. So this is the current transformer. What you are seeing is current transformer. Yeah, this is PTs, potential transformers, voltage transformers. Then next is surge arresters. So surge arresters for lightning arrestor, lightning, any faults happening means that surge arrestor will protect the whole substation. Okay, so this is the reactive power plant. As I said, the reactive power plant, like a series of capacitor banks and reactors combiningly, they will install to suppress the reactive power. Yeah, this operation. So normal operation. So how the power is flowing. Have you seen? Yeah. So here now the circuit breaker is not in operation. So yeah, disconnected operation. So you're seeing here, no? So one worker is disconnecting that particular thing. Okay, particular circuit. Okay, this is called disconnector. So while disconnecting the circuit, the worker has to wear the glove also. Okay, sometimes even though rod is insulator, sometimes due to the insulation failure, sometimes directly that same power is coming to that particular line. Okay, that current is coming to the particular line. So always that worker has to wear the glove and see the helmet, everything, and the shoes. Shoes means normal shoes, they should not wear. Like there is a special type of shoes. Okay, so that's why we are insisting in lab to always wear shoes. Okay, so sometimes any electric shock happens also, you may resist from the ground. Okay, so if it is connected to the ground, you will feel a heavy shock. So if you wear thick heels shoes, then you will be protected. Somewhat you will be protected, even though the line will be passing, but you will be protected. Okay, so if it is grounded, if you are not wearing shoes, okay, uh, then you're standing and you're touching the line, means directly it will the line will flows to you and to the ground. So directly it gets shorted, so you will feel heavy shock. Okay, so this is also that, this is the disconnector. See how it is disconnecting. So one rod might be there. So if you turn that rod, automatically this line will disconnect. Okay, disconnect that particular feeder. Okay, particular circuit. So this is the earth switch operation. Okay, earth switch. So everything will be earthed. Then now the circuit breaker is fault. The center circuit breaker is fault now. Okay, see how the circuit is the current is flowing now. Yeah, here. So now the bus zone 1 is fault. Okay, this zone is fault. Okay, so how it is like overcoming. So this is also bus zone 1 is fault. This whole line is fault. I think again the thing is repeating. Okay, so now we'll see the some other videos. After this, I think uh, uh, you can visualize. So whatever I'm telling, you can visualize. Otherwise, you'll be telling, you'll be feeling what is disconnector, what is circuit breaker, and what is current transformer, what is PT. I think in theory you can study the working and all. So practically, how you can see. One second.
When you plug in an electric device, it's easy not to even consider where the electricity When you plug in an electric device, it's easy not to even consider where the electricity actually comes from. The simple answer is a power generating station, also known as a power plant, usually someplace far away. But the reality is much more complicated than that. Generation is only the first of many steps our power takes on its nearly instantaneous journey from production to consumption. The behavior of electricity doesn't always follow our intuitions, which means the challenges associated with constructing, operating, and maintaining the power grid are often complicated and sometimes unexpected. Many of those challenges are overcome at a facility which, at first glance, often looks like a chaotic and dangerous mess of wires and equipment, but which actually.
So the thing is that without the power station, without the substation. Okay, so without the substation, if it is that, say for example, no substations are installed, directly generation is happening. Okay, directly you're transmitting the power. Say for example, directly you're transmitting the power 11 kV or 25 kilovolt is being generated. Okay, you're stepping up to 400 kilovolts. Okay, you're directly transmitting this to some 300 kilometers. Okay, 300 kilometers. So imagine no substations are there. No substations are there. Then then the work becomes very very complex, because 400 kilovolt is now coming to nearby your house. Say for example, 5 kilometers apart from your house. Okay, 5 kilometers apart from your house, 400 kilovolt is coming. So even though you can install one transformer, who is going to look over that? Who is going to look over the current? Who is going to look over the power factor, frequency, everything? So the substation did that work. Okay, so that's why the definition of substation goes like it is an assembly of apparatus. Substation is an assembly of apparatus in which you can change the voltage or change the frequency, okay, power factor, everything. Okay, it is an assembly of apparatus. So assembly of apparatus like power transformer, circuit breaker, then potential transformer, disconnectors, then surge arrestor, okay, like insulators, like many things combined together to form a substation in which we can, and also capacitor banks for okay, maintaining the power factor, reactive power. So everything combined together into a building or a closed structure, sometimes closed structure, sometimes open structure. That also we'll see why it is opened. Okay, why it is open, that also we'll see. Some accident videos also there. So I can explain you clearly when that video I will play. So now I'll.
It serves a number of essential roles in our electrical grid. The substation. I'm Grady, and this is Public Works, my video series on infrastructure and the human-made world around us. This video is sponsored by NordVPN. Visit nordvpn.com/practical engineering to get 75% off a 3-year plan. More on that later. As simple as it is to imagine, the power grid isn't just an interconnected series of wires to which all power producers and users collectively connect. In reality, the electricity normally makes its way through a series of discrete steps on the grid, normally divided into 3 parts: generation, or production of electricity; transmission, or moving that electricity from centralized plants to populated areas; and distribution, or delivering the electricity to every individual customer. If you consider the power grid a gigantic machine, and many do, substations are the linkages that connect the various components together. One of the cool parts about our electrical infrastructure is that most of it's out in the open, so anyone can have a look. I'm somewhat of an infrastructure tourist, a regular beholder of the constructed environment, and my goal is for you to be able to mentally untangle this maze of modern electrical engineering so that the next time you feast your eyes on a substation, you will be able to appreciate it as much as I do. Originally named for smaller power plants that were converted for other purposes, substation is now a general term for a facility that can serve a wide variety of critical roles on the power grid. Those roles depend on which parts of the electrical grid are being connected together, and the types, number, and reliability requirements of the eventual customers downstream. And the first and often simplest of these roles is switching. The general layout of a substation consists of some number of electric lines, called conductors if you want to fit in with the electrical engineers, coming into the facility. These high voltage conductors connect to a series of some or many pieces of equipment before heading out to their next step in the power grid. As a junction point in the grid, a substation often serves as the termination of many individual power lines. This creates redundancy, making sure that the substation stays energized even if one transmission line goes down. But it also creates complexity. The connections to these various devices are called buses, often rigid overhead conductors that run along the entire substation. The arrangement of the bus is a critical part of the design of any substation because it can have a major impact on the overall reliability. Like all equipment, substations occasionally have malfunctions or things that simply require regular maintenance. To avoid shutting down the entire substation, we need switches that can isolate equipment, transfer load, and control the flow of electricity along the bus. This may seem obvious, but turning on and off high voltage lines isn't as simple as flipping a light switch.
So 1 minute, I'll show you the bus. Yeah. So here in this video, you're seeing 3 lines, no, R, Y, B. So red, Y, and yellow and blue. Okay, so these 3 lines are called bus. Okay, so what is bus? Bus in the sense, okay, generally, normally, normal bus, what it will do is, so all the buses goes to the bus stand. Okay, so general one bus stand will be there, like I think Jubilee bus station will be there. So Jubilee bus station, all the buses will be going to Jubilee bus station, then only it is going to the wherever it want. Okay, so to that particular route, say for example LB Nagar, Mangalpalli or Ibrahimpatnam. So whatever the all the buses goes to the particular bus stand, and again it flows to the particular route. So here also there is one called buses. So in this like hollow okay, aluminum or copper rods will be there. Okay, so incoming and outgoing lines will be flows to that particular buses. Okay, say for example 110 kilo 33 bar 11 kV itself will take. So 33 bar 11 kV. So 33 is coming into the line. Okay, so after some process, it will flows to the bus. So again after that bus, okay, after that bus, again it flows to the like some other transformer again the 33 to 11 kV, then 11 kV flows. Okay, so definitely it has to flow in that particular bus. Okay, like after this process, I think after this video you can understand clearly. Then the layout also you can understand clearly. Okay, so after some process, it will flows to the bus that bus bars. Okay, that is hollow line. I will show some videos also. Hollow tubes, aluminum tubes or copper tubes. Generally, copper tubes are very costly. You know. Okay, copper conductors are very costly. Most of the substation they are going for aluminum rods, same work only. Some little bit percentage difference might be there, conduction little bit like point 1.5, like that little bit this thing is there, but same work this also did rather than the copper conductor. But you have to install copper conductor only due to the costly copper is very costly. We are going for mostly aluminum
Voltage
rods.
lines isn't as simple as flipping a light switch. At high voltages, even air can act like a conductor, which means even if you create a break in the line, electricity can continue flowing in a phenomenon known as an arc. Not only does arcing defeat the purpose of the switch, it is incredible.
So while like opening the switch, this arcing will come. This is called arcing effect. I think where you studied, yeah, in like in your protection subject. I think protection subject. I think next semester you are going to study this arcing concept and all.
Incredibly
So once
dangerous
you
and
see
damaging
this,
to equipment. So switching in a substation is a carefully controlled procedure with specially designed equipment to handle high voltages. Disconnect switches are often just called switchgear, in addition to the equipment that serves another important role in a substation, protection. I mentioned earlier that much of our electrical infrastructure is exposed and out in the open. That's nice for people like me who enjoy having a look, but it also means being vulnerable to an endless number of things that can go wrong. From lightning strikes to rogue tree limbs, windstorms to squirrels, grid operators contend with.
so sometimes directly your lightning might be directly passing through your transformers or insulators, circuit breakers, potential transformers. So if it is directly passes to your buses or the thing is that, so it will flow like the voltage will be like 11,000 sorry, it will flow like 10 times 20 times more than that, more than the voltage. Okay, so 11,000 volts it is passing, not 10 times more than the voltage it is passing to the particular buses or particular lines. So it will damage your power transformers, CTs, PTs. So power transformers and all very, very costly. If you see that power transformer, I will show you a video. If you see that power transformers, so 6, 7, 8 fans might be there. Okay, so side 8 fans might be there. Sometimes air cooled as well as the oil cooled plus air cooled. Okay, so that because that power transformer is working for 24 into 7 into 365 days, so they will be having reserve transformer also. So sometimes due to the fault they might be changing, but even though that power transformer is operating for 24/7 into 365 days. Okay, so so always it is operating. So it is oil cooled and as well as air cooled, oil cooled transformer and as well as oil plus air cooled. Okay, so fan also might be there. Fan also might be running for always 24/7. So that your power transformer will be always cool. And also in that substation, that oil viscosity also they may check frequently whenever is not in operation, like even weekly once, they, because it is operating, because this faults now again, whatever the area connected to that particular substation, the whole will get spoiled. So this power transformer is like heart of the substation.
So many threats to their infrastructure on a day-by-day basis. When something causes a short circuit on the power grid, also called a fault, it can severely damage power lines and other equipment. Not only that, because of the overwhelming complexity of the power grid, faults can and do cascade in unexpected and sometimes uncontrollable ways, leaving huge populations without power for hours or days. Many of the ways we protect equipment from faults are handled at a substation. One of the
So any fault happens means so automatically the circuit breaker will trip. So if it is not tripping means again everything you need to connect, that will take more time without the circuit breaker until.
most common types of electrical fault is a short circuit to ground. This type of fault creates a low resistance path for current to flow and leads to an overload of power lines and equipment. The simplest way to protect against this type of fault is with a fuse, a device that physically burns out at a certain current threshold. Fuses are dead simple and don't require much maintenance, but they do have some disadvantages too. They're one-time use, and they can't be used to interrupt current for other types of faults. On the other hand, circuit breakers are a class of device that serves similar roles as fuses, but provide more sophistication for dealing with a wide variety of faults. Like disconnect switches, circuit breakers need to be carefully designed to interrupt huge voltages
So
and
what you're seeing is disconnector
currents without damage. As soon as contacts within a circuit breaker are moved apart from one another, an electrical arc forms. This arc needs to be extinguished as quickly as possible to prevent damage to the breaker or unsafe conditions for workers. Extinguishing the arc is accomplished by a material called a dielectric that doesn't conduct electricity. For lower voltages, the circuit breakers can be located in a sealed container under vacuum to avoid electricity conducting in the air between the contacts. For higher voltage, breakers are often submerged in tanks filled with non-conductive oil or dense dielectric gas. These breakers give grid operators.
So your circuit breakers are of oil circuit breakers are also there, and also vacuum circuit breakers for higher voltages. Sometimes oil also might be losing that insulation, like insulation. So in that scenario, they are going for vacuum circuit breaker. Okay, vacuum circuit breaker. I think you're already studying that concept, vacuum circuit breaker.
There's more control about how and when current gets interrupted. Not every fault is the same, and sometimes operators even know about a disturbance ahead of time and can trigger breakers early to prevent cascading failures. Many faults are temporary, like lightning strikes or swaying tree branches. A special kind of circuit breaker called a recloser can interrupt current for a short period of time and re-energize the line to test if the fault has cleared. Reclosers usually trip and reclose a few times depending on their programming before deciding that a fault is permanent and locking out. If electricity demand on the grid gets so high that it can't be met by the utility, substations may also be used to shed load. Rolling blackouts are used to lower the total electrical demand to avoid bigger failures on the grid. One of the most important parts on the power grid is that different segments flow at different voltages. Voltage is a measure of electrical potential, somewhat equivalent to the pressure of a fluid in a pipe. At large power plants, electricity is produced at a somewhat low voltage of around 10 to 30 kilovolts, or kV. From there, the voltages increase much higher so that it can travel along transmission lines. Using a higher voltage reduces the losses along the way, making them more efficient, but also much more dangerous. This is why overhead transmission lines are so tall, to keep them out of the way of trees and human activities. But when transmission lines reach the populated areas which they serve, it's not feasible to keep them so high in the air. So prior to distribution, the voltage of the grid needs to be brought back down using transformers located within a substation. A transformer is an extremely simple device that relies on the alternating current of the grid to function. It consists of two adjacent coils of wire. As the voltage in one coil changes, it creates a magnetic field.
So what is the definition of transformer? A transformer is a static device which converts one form of the voltage to another form of the voltage without changing the frequency. Frequency is not changing, that is kept constant. Okay, so always while writing, many of us I am seeing, even in the final year, so I will be asking the Viva, what is transformer? They will simply say transformer is a device which converts one form of the voltage into another form of voltage. That's it. So without changing the frequency is very, very important. So change frequency is constant in the transformer. So that is the specialty of the transformer.
Field couples with the other coil, inducing a voltage. The incredible part of a transformer has to do with the number of loops in each coil. The induced voltage will be a function of the ratio of the loops. For example, if the transmission side of a transformer has 1,000 loops, while the distribution side has 100, the voltage on the distribution side will be 10 times less. This simple but incredible fact makes it possible for us to
So what you are seeing is step-down transformer. Step-down transformer, say for example, 33 kilovolt is incoming. So 11 kilovolts we want means, so that much windings we have to reduce. Okay, so 33 is more, then 11 is somewhat less. So 33 bar 11 kV or 66 bar 33 kV, 110 bar 66 kV, then 220 bar 110, 220 kilovolt bar 110, then 400 kilovolt bar 220, or 765 kilovolt bar 400. Like that, whatever the ratio. So you have to change the windings in that particular transformer.
Step up or down voltage as necessary to balance the safety and efficiency along each part of the power grid. The simplicity of transformers is great in a lot of ways, but it also means it can be difficult to make fine adjustments to the power leaving the substation. Because of this, many substations include equipment for monitoring and controlling the power on the grid. Instrument transformers are small transformers used to measure the voltage or current on the grid or provide power to system monitoring devices. Depending on the varying transmission and distribution losses, the voltage on the grid can also swing outside an acceptable range. Regulators are devices with multiple taps that can make small adjustments up or down to the distribution voltage on feeder lines leaving the substation toward customers. If you look closely, you can sometimes see the regulator dial indicating the tap position. All that different equipment requires lots of maintenance. The final and most important role of a substation is that it be safe for electricians and linemen to inspect, repair, and replace equipment. Substations are usually the only locations where extra high voltage power lines get close to the ground, so safety is absolutely critical. The buswork running along the substation is protected from short circuit by large insulators to avoid arcs to ground. Even the connections into each piece of equipment are done through a
see these fans. Okay, so how many fans are there? 6 fans are there. So like that, more fans also might be installed. Why? Because so this substation is always in the operation. Okay, because if the substation is not in the operation, then we will not able to receive the power in our houses as well as industries, wherever it may be. So substation, from the substation only we are receiving the power. So always it is in operation. So wherever it is necessary, they will install oil cooled current transformer, oil cooled potential transformer, oil cooled circuit breaker or vacuum circuit breaker. Then your transformer also oil cooled plus air cooled. Like that, wherever necessary, they may install this like fans also.
Device called a bushing, which maintains a safe distance between energized lines and the grounded metal housings. Some substations have large concrete walls to serve as fire barriers between equipment. All substations are built with a grid of grounding rods and conductors buried below the surface. In the event of a fault, the substation needs to be able to sink lots of current into the ground to trip the breakers as quickly as possible. The grounded grid also makes sure that the entire substation and all its equipment are kept at the same voltage level, called an equipotential, so that touching any piece of equipment doesn't create a flow of electricity through a person. Finally, substations are surrounded by large fences and warning signs to make absolutely sure that any wayward citizens know to stay out. In many ways, the grid is a one-size-fits-all system, a gigantic machine to which we all connect, spinning in perfect synchrony across, in some cases, an entire continent. On the other hand, our electricity needs, including when we need it, how much we need, and how reliably it should be delivered, vary widely. Power requirements are vastly different between a sensitive research facility and a suburban residential neighborhood, between a military base and a country club golf course, and between a scalable energy to curb global warming. Managing our electrical infrastructure will only get more challenging. So substations will continue to play a critical role in controlling and protecting the power grid. Just like electricity on the grid, internet traffic goes through several steps along the way. As I sat in the airport writing this video, I was definitely wondering if one of those steps might be a hacker or organization recording my traffic. Unfortunately, people have come up with lots of ways to intercept web traffic and use that information nefariously, which is why I use North Pro. I don't use their Wi-Fi or any other public.
Okay, so I hope you're